Chapter 33, Fundamentals of Hydraulic and Air-over Hydraulic Braking Systems, Day 2, Video 7, Combination Valve. Okay, so there are some inherent problems with the hydraulic brake system. So we have some different components in the system to compensate or to make up for those problems. First one we'll talk about is a proportioning valve. So what that does is reduces brake pressure to the rear wheels when we are under hard braking. Right. So one of the things that happens is with the truck, as we slow it down, right, we're starting to slow the truck down, the momentum and then the load shifting of the weight from the load is shifted forward on the truck. So what that's going to do is take some of that the force or the weight that's over those rear axle or the drive axle and transfer it to the front axle. So we were taking some of the weight off of that rear axle, and now the brakes would be too strong on it, and there's potential there that the brakes would lock up and slide. So the harder we make the braking application, the more weight transfer we get, the lower the weight is over the drive axle in the secondary brakes, and more is shifted to the primary brakes on the front axle. So we want to start limiting the pressure that we send back to the rear brakes the harder that we brake that system. So we can use a proportioning valve that will do that. A couple different ways to do that. Through a direct linkage between the rear axle and the frame. So the more weight we put on it, it's going to compress the suspension, meaning we've got more weight over those rear tires, and then we can allow more brake pressure to the rear brakes. Or we can do it automatically through brake pressure, just understanding that the harder I push down the brakes, the more weight transfer is going to happen, the more I need to reduce the pressure over the rear axle or to the rear brakes. So it does that automatically. So due to the changing weight over the brakes, we'll have a proportioning valve that will start to reduce the pressure to the rear brakes. The metering valve, if we've got a combination disc drum system, front disc brakes, rear drum brakes, right? So one of the things that happens is we have better braking action with the disc brakes, so we'll put them on the primary brakes from the front of the vehicle. So as that weight transfer happens, we've got those transferring to a better braking system. But the one problem we have with the disc front and drum rear brakes is the disc brakes actuate a lot faster than the drum brakes. Lower pressure and lower volume of fluid will cause the disc brakes to operate, and we want those to begin to work at the same time. So we'll put a metering valve in there that slows down the pressure going to the front disc brakes, so that once they start to actuate, the drum brakes in the rear should actuate at the same time. So we're going to slow down the application of the disc brakes in the front so that the disc brakes and the drum brakes apply at the same time. So we'll use a restriction in the system to do that. And then lastly, a pressure differential valve. So what that does is measures the pressure in our primary and our secondary side, and which they should be, when they're created, the pressures are created, they should be at the same pressure. So that 5 pounds in the primary will create 5 pounds of pressure in the secondary. But if we have a problem in the system, broken line, and now we lose pressure in one of those systems, we use a pressure differential valve to monitor that. So what we've got here is a combination valve. We have all three of those valves we just talked about in one brake valve. Brake line's coming into it. So this valve is going to be, we have the master cylinder here, the tubes coming out of the master cylinder right into this proportioning valve. So this is the easy way to find that. All right, so let's talk about the proportioning valve here in the back. Brake pressure coming into it here. So we've got secondary brake pressure coming in and acting on this piston here. All right. So the harder I'm making a brake application, the more it's going to close this piston and restrict the flow going to the rear brakes. The thought there being, remember, if we're making very hard brake application, it makes sense that we're going to transfer more weight from the rear to the front braking system. So we need to start limiting the braking to the rear brakes to counteract that. So the harder I push down the brakes, the more it's going to start cutting off flow to the rear brakes to counteract that weight transfer to the front brakes. The metering valve here, so the front brakes here, we've got the pressure coming in here, and what it's going to do is we've got a piston in here, we've got some springs behind it pushing that piston against this stop here, closing off the flow. So what it's going to do is slow down the application of the front brakes. That pressure coming in here, we've got the same 5 pounds coming in the primary as the secondary side, will flow out to the rear brakes. But the first thing that has to happen on the primary side is to compress the spring a little bit, and then now the fluid can flow out and around to the front disc brakes. Right, that's going to slow those disc brakes down just a little bit. And then the last one here is that the pressure differential valve. Whatever pressure, we're still going to have the 5 pounds working on the primary and secondary side of the brake chamber. So that 5 or 10 pounds is coming in, working against this surface area of this pressure differential valve. Same surface area here. So this valve will not shuttle back or forth because the pressure is equal on both sides. Now let's say we break a brake line out here, we run over a pallet or something like that, and it comes up and breaks puts a hole in the brake line, and now the pressure is leaking out. The pressure would be lower on this side, right? Less pressure pushing this way in the piston. The more pressure pushing this side of the piston is going to cause this piston to shuttle over, and now this pin will raise up, make a connection, close a ground circuit, and then you'll have a warning light come on the dash, letting you know that you have a problem in your brake system. You pull over and see what's going on.